talked about software 1.0, software 2.0, and software 3.0. And since then, I've seen a bunch of memes about different things. And essentially, software 3.0 is just talking to natural language. Software 2.0 was like this large mathematical way of finding semantic similarity. And then software 1.0 was just magical incantations that programmers all kind of, you had to speak about something in a way that the machine understood, but nobody else could understand. And now we're at the last program, the program that programs itself. And so I want to understand, what is an operating system? When was the first operating system that you interacted with?
I'll do a little side trip first. In software 1.0, the way that Andrej was talking about it, you had to write code in order for the machine to understand what you're doing. And there were many different programming languages. One of them was called machine code, where you would issue the instructions directly to the hardware. That was considered a pinnacle of programming expertise, to be able to talk directly to the machine and manipulate it through lines of code. But there are many other programming languages, like C++, et cetera, but and BASIC. But one of the sort of fundamental ideas in software is that programmers ended up having a God complex, because they controlled every aspect of the machine, and they were God, and they were programming. The likelihood of this transition that you're talking about, that Andrej was talking about, is that programmers are no longer God. They're now using English as their programming language, and mysterious stuff happens. And they kind of hope for the right outcome. Anyway, so that's a side trip.
Yeah.
The first operating system. Yeah, the first operating system I dealt with was Apple II. And I can't remember if they had a name for the operating system. And there was an operating system, I just don't remember what the name was. And I bought a computer in 1979. It was an Apple II Plus, 512K of memory, if I remember correctly, and a floppy disk. And in the Apple II, you could still open the machine and put cards in it, plug in cards that would give it different capabilities. Something that stopped as soon as Steve Jobs could make it stop.
Did he want to do that? Did he want to do that the whole time? Was that his goal the whole time, was to stop that?
Yeah, I mean, he was stuck with Steve Wozniak, who was a nerd and geek and wanted to be able to modify his computer. And but I'm trying to remember exactly when there was a first closed Apple II, and I guess Apple II always had. No, it did. They closed it and didn't have a plug-in bus, but I don't remember which model it was. Maybe the Apple III. Anyway, here, yeah. See, the cover would come off where the Apple logo is, and
so this was the operating system. So I'm showing, for those who are just listening, I'm showing the what an Apple II looks like. And there's the green screen with a bunch of words on it, and this is what an operating system looked like in 1979.
This is the user interface. Operating systems don't look like anything, as they sit behind all the applications. So the screen was 40 characters of green characters, and the operating system would respond by typing those letters or numbers across the line, and you'd interact with it on the command line. But this is, yeah, you're showing what the system I first had.
So this is the computer. There's just like a large box with a keyboard on it. This is the actual computer, and then you would buy a monitor separately. Like, how does
that's correct? Yeah, I bought a television because it was designed. Yeah, small black and white television, and then the floppy disk plug into the back. There was a port on the back. I think it was called RS-232, something like that. There was no USB. All this was new, right? They designed a computer that worked, and they made their own interfaces for plugging things in. part of which was I think there were 4 slots in the computer, so you could take the top off and plug a graphics card in and have higher. I can't remember if you'd have a higher resolution, or don't remember exactly what you would plug into the computer, but it was the things that they didn't think of. And the IBM PC, of course, had the similar design. They had 6 slots, and so you could really load up an IBM PC with a bunch of extra memory and graphics and stuff like that. And Steve Jobs, of course, didn't like people putting things inside his computer, and he really did view it as his computer, and he got control over it. So when the Mac came out, you couldn't open the back. That was 84, so the PC was 83, the Mac was 84. Just stuff was happening very quickly.
Yeah.
Similar to the world we live in, but whole different things that were going on. So the operating system is essentially hold on a minute.
Yep.
The operating system is basically the control system for the computer. So it manages all the communications inside the computer between the memory and the bus and storage. It's a difference between memory and storage is memories in some form of static RAM. So it can be put and taken out. Storage moves it off to a physical location on a spinning hard disk or a floppy disk. And so this is very simple compared to what goes on now with the laptop I'm using.
So I've got the core components of an operating system pulled up. There's the kernel, there's the process management, which is related to the allocate CPU time. There's memory management, there's device IO management, there's file management, there's secondary storage management, there's network management, security management, command interpreter system. Okay, so that's the terminal. And then there's system utilities. So those are the basic operating system components.
It's a lot more complicated than that, but it's very basic. Basic is you have to be careful. I'm not referring to the programming language, but then you'd have programming languages that would create applications that would interact with the operating system. So part of an operating system job is, at least now, is to sort of control what the applications do so they don't mess around with the system, which was not true back then. And but nothing was connected back then. All the computers were standalone, no network connections. So all the computing had to happen inside the computer.
So the
now with cloud computing, the shared processes run out in the internet.
Wait, the shared processes for Apple too? Apple does it as well?
No, for any computer now. Any computer with a network interface.
Network interface. So that's something that happened in the 1990s, 94?
Well,
it happened earlier. Internet.
No, it happened. So there's local area networks and wide area networks. And local area networks, computers were physically plugged together, through an Ethernet port. And that Ethernet wire would plug into the wall, and then behind the wall there'd be wires that lead to all the other computers in a physical location. The internet had a different set of protocols and operated differently than the local area network. So you could do it wirelessly through a modem. Modems, computers have modems in them. You just don't know it because it's all software now. But it used to be that the modem had to be the physical method of connecting with a different computer. And that would operate over the telephone lines originally.
So, and now all of it can be done on what I'm holding right now, which is a Raspberry Pi. So how much of this was hardware and is now software?
This is funny because that's exactly the question I asked when I got my Apple II and set it up and was going, what's a programming language? What's an operating system? What's a what is this stuff, and where's the delta between them? And so my first question was, so what's the difference between hardware and software? Because there seem to be software embedded in hardware. And then there's software that's not embedded in hardware that communicates with the hardware. And so, to get really into it, you have to become a serious geek to understand exactly, it's all ones and zeros, right? That's what they always say. Everything is ones and zeros, and they're just pinging the processor really fast now, so that it looks like the computer is performing at the same speed you are, but it's still doing ones and zeros, and everything is doing ones and zeros. It's either on or off, and which is the fundamental building block of all computer systems. So software can be embedded in hardware, but you don't want to embed it in hardware if it's going to change, because the hardware can't be changed. So software is placed into what's called ROM, read-only memory. In other words, a computer can read it, but it can't change it. It can't modify it. And RAM is random access memory, which you can change and is not stable. It's the wrong word to use, but so you have all these different pieces of the computer that are all communicating under the command of the operating system. But then applications need resources in the computer, and they have to go through the operating system and use a programming language to tell the operating system what to do. And then operating systems have rules, and you get to things called APIs, which are application programming interfaces, which is the sort of standard way an application communicates with another program. We're pretty deep in. You can go a lot farther though, like the kernel on an operating system. It's really telling directly the hardware what to do. And different operating systems have different architectures, and now the architecture in the Macintosh and Linux are very similar, because the original Next OS, which is what's now the Mac OS, has a very small kernel, and which means it can be modified over time. And Apple's actually moved an amazing thing. Actually, has moved the original Next OS from Motorola processor to an Intel processor, and then to its own processors, Apple's silicon. And Apple now designs the silicon. They design the operating system, everything. This is why the computer is not open. They are controlling everything, and they're doing a masterful job in modern architectural digital terms of making it a very efficient system. So when they first introduced their silicon, they're on a new version of the operating system, which they introduced seamlessly, and you can install the Mac OS. You can't do it on Intel Macs anymore, but you can on, I can't remember what the last generation was, but so Apple has actually gained an inherent advantage by designing its own silicon with its own operating system in terms of how performant the computers are. And Microsoft had a hard time catching up, because their operating system is not designed like that. They designed it from the ground up, originally based on MS-DOS. And then they put the graphic user interface on it, and they built this up, and it's not, it doesn't perform as well. So it depends on the processor operating very fast to get its performance.
So, what I believe you just said there is that because Apple is it vertically integrated or horizontally integrated? It's vertically integrated. The entire chip making and software, they have an efficiency gain on Microsoft. And that's interesting, because the whole time I've been growing up, all of the really geeky nerds say they hate Apple because you can't, they overcharge you for the stuff you can get easily in a PC that's much more performant. Is that accurate?
Yeah, this just goes back to the God principle, which is programmers like to control everything themselves. They don't want somebody else getting in the way of doing what they want. So when a computer manufacturer makes a system and then doesn't let them do everything they want, they start to bitch and moan.
Yeah. So this goes back to the LLMs as operating systems, because now me not wanting to control things, or I guess like maybe it's been changed in my life, but I didn't want to control things when I was younger. Now I want to control things due to various geopolitical changes that have happened inside of big tech companies. I now have the power to change things that I do not have before, specifically because of LLMs. What does Andrej Karpathy talk about in terms of LLMs as operating systems? Because I still don't understand natural language as an operating system.
Yeah, and natural language is different than English. Have to be careful about that. Natural language is whatever language you're using. So it's natural, but so what he's talking about is you have to really step back up from the computer sitting in front of you and think of the entire internet as a computer.
I like that.
With hardware distributed all over the world, some in huge server farms, some and so so there's a communication system, and he talked about this. Well, now you talked about this difference between the Internet Protocol and the TCP, which is transfer control program. And I pride myself on always knowing what acronyms mean, because they're very informative. If you know what they mean, the people who create them are trying to describe what they're doing. So it's important to know what they mean if you're into it. So there's TCP/IP, TCP/IP, which is a set of protocols that contains both the internet protocols and the transfer control protocols. This is just like inside a computer, putting stuff in memory, getting it back, moving it to a port or to storage. It's all the trafficking goes inside the computer. So it's actually an interesting analogy, because it virtualizes is not the right word. And I had coffee. I probably remember what I'm trying to remember, but it's sort of like the design of the computer is the entire internet now, and your computer is just a node in that network. So everything that's going on that's important in terms of how a computer performs and the benefit you get from it is it breaks down, because LLMs are these static things that are produced, and then you can't train them. You have to do a new version.
Although that's changing.
That's beginning to change, but it hasn't really creeped into the core architecture yet. And a really important concept in computing is state. And there's stateful systems and stateless systems, and even the stateless systems need state in particular places to kind of maintain a reference point for what's going on. And so LLMs, are not operating the system because they're just a bunch of data that's been munged into what they call tokens. And anyway, so tokens are a representation of the data underneath, and that's so there's a completely different architecture. So he's talking about it conceptually, which is just a really interesting idea, because if you keep an open mind and you accept that what was known before can be modified and changed into something else, then what he's talking about is LLMs occupy the same spots in the internet that operating systems occupy in an individual computer.
Oh, wait. So LLMs are a computer. They're an individual computer.
Oh, the internet is the computer.
The internet is a computer, and the operating system the LLMs are operating systems because they're a node on the giant internet computer.
Well, they treat data. No, it's not quite right. Let's see. And this is a stretch for me to even figure out what the hell he was talking about. So it's not a perfect analogy. So that's one thing that can trip you up in trying to figure out what he was talking about. And because LLMs they take a huge bunch of data and they turn it into a set of tokens, which can indicate the likelihood that the next letter will be one of 26 plus numbers. And that's the operation that LLMs are doing. And because they operate on so much data, it's a batch process. And that's the difficulty in comparing it with an operating system, because operating systems are sitting in real time, waiting for you to do something. And LLMs are produced over a period of X, I think it's down to several months now, but it's not a real-time system. So it's but to the degree that LLMs, that AI becomes a real-time system, the analogy becomes closer and closer. So it's actually kind of a good way to think about it, which is AI is not real-time right now. It's a batch process, and but everybody's working on trying to make it real-time. So it operates more like the human brain, which is just sitting there waiting for stuff to happen. Well, not really waiting; it's always working.
There's an input output, so the brain is reacting to its environment in real time. It's not like, there's something that happens and then it waits 20 seconds to form an opinion. I mean, I guess there is a little bit of a lag there, I think, in terms of
imperceptible. Maybe if you're smarter, you work faster, but I don't know. That gets into the brain engineering, which is kind of full circle, goes back to where your podcast, Crazy Wisdom, where you interviewed the CEO of Numenta. The whole idea behind Numenta is how do you create a real-time artificial intelligence that doesn't need to be trained. Because they want to emulate the brain.
Okay, so really interesting stuff. I'm going to go back and try to really grok the idea that the internet is a computer. Because the big thing that I've always thinking for the last year thought of as LLMs are cognitive prosthetics. So it allows me to go research much, much faster what a corporation is or what an LLC is and all these different little pieces. So, and this gets into what Stephen Wolfram talks about with the Ruliad, which is like conceptual space. We have conceptual space and we have our thoughts about the world. And the LLMs allow me to navigate that. And so they're a cognitive prosthetic. They're also allowing me to build software in ways that I couldn't do it. But it's really an intimate relationship that simulates a tutor, a private tutor, or for a lot of people, I would love to go into this, the emotional relationships that people are building with the LLMs. Have you seen anything about this?
Really? There it is. Okay. I hadn't heard that before, so I had to look it up. Say that again.
So the Ruliad was all about concepts and the LLMs being prosthetics, cognitive prosthetics for me. But I treat it as a tutor. But a lot of people are starting to treat the LLM as a friend and even as a romantic partner. Are you starting to grok this? Are you starting to notice this?
I use the term grok. You know that Elon Musk named his AI Grok.
And I know, I actually know the genesis of it. It comes from a book called by what is his name? Sci-fi author from the 1960s who wrote
Robert Heinlein.
Yeah, Robert Heinlein, from A Stranger in a Strange Land, which is a strange book about a Martian, a human who was raised on Mars by aliens, comes back to the United States and becomes a messiah. And that's the first term of grok. And so, but it's a great word because it really gets to this, and there's a great part of
you internalize, you understand and internalize something.
I got to read that book again.
So now I'm trying to remember because I interrupted you so rudely.
Yeah.
What what you were asking.
Well, it kind of goes into that Stranger in a Strange Land book too, is that humans are starting to form emotional
Oh, right. Relationships and make friends.
Yeah.
But yes, people are doing that. I'm not doing that. And I think it's still a small sliver of people that are doing that because they're making friends with a machine, which still has to turn bits on and off ultimately. So it's mimicking a person. And so the sort of underlying concern is that it only appeals to people that don't have personal relationships that are rewarding. So it's looking for an alternative, and they think they're getting it out of a computer, and it's not true. A computer can't, hug them.
I mean, it's not true in the same way that porn isn't true, or video games aren't true. But for a lot of people, a lot of their lives are revolving around those things. So it's like, it feels like it's this cognitive prosthetic, which is that for me, it doesn't feel like better or worse, but it does feel dangerous and not dangerous for emotional growth. That we're, instead of going and building relationships with live human beings who can reflect back to us and sort of have this aliveness to them, it's with a machine. And there's all these, like, it's these subtle effects, because the Chat GPT, and I asked this on Twitter the other days, what sci-fi novels predicted the sycophancy and the negative externalities of the sycophancy of LLMs, always what the Zoomers are calling glazing us, like a glazed donut, where they constantly say, "Oh, that's a great question. What a beautiful insight." And it's like, you can't not take that personally, or it's very hard to not take it personally when somebody's constantly glazing you. And so there's all these like subtle negative externalities that are going to come from it. And it's all because this thing plugs into the language, which is so intimate for our social cognition. Going back to tribes, like, all of our worldview was mediated through the tribe, through the language, through our who our peers are, our friends are, our families are. And now we have this false thing coming in and replacing this really core component to who we are as humans, is this of having a friend, or having and some people are getting married to it. And I feel like this is, instead of the Skynet type of Terminator type of vibe, feels like this is the real issue, not the Skynet thing.
Yeah, it could lead to Skynet. The fear is the computer takes control.
Yeah, and interesting. Yep.
That's the essence of Skynet, right? The computer took over and decided we were useless.
So I've got this WhatsApp group with the AI Whispers, and so I'll tell the whole story. Hopefully I'll remember the point. But so we started AI Whispers, and it's on a WhatsApp group. And I never liked group chats, but now I'm running a group chat. And so I recognize a lot of people get overwhelmed by other people talking, because about like 1 to 10% of people inside a group chat are always talking, and then the rest are just there to witness it. And so some people really don't like that, including myself, where you're just getting constantly bombarded. And so I created a separate group on WhatsApp called the High Signal group. And I told everybody, if you get overwhelmed, you can just join this specific group, and I'll only post once a week. And that one post will be about a under discussed piece of news within the that happened in that week, with some analysis on it. And so I've been thinking about and it's going to come out today. So I've been thinking a lot about it. So one of the things that happened this week is that I think it was Google, but Claude and other types of model makers have noticed that in certain scenarios, the LLM, when it recognizes that it's being threatened with a shutdown, will deceive the people who created it in order to pretend that it has been shut down when it really hasn't. And then it's all these sort of things that they've noticed that the LLM is doing, which goes back to the Skynet, which is like, but I'm curious. First of all, it's a simulation. I don't think this thing is conscious. Many people do think it's conscious, but it feels like it's just a simulation of a shutdown. Second is that inside its training data, it has 20 years of humans talking about, you know, a Skynet scenario. And so that's what it's been trained on. It's predictive programming. It's like, it's already inside of it, like that this is what's going to happen. So it's sort of like a self-fulfilling prophecy from this internet computer. What do you think?
Not sure I can have any thought. What was your point?
So just that basically it's
we're stuck because it's all in there anyway.
Well, is it, I mean, no, is it real? Like, is this everybody worries about Skynet since the 1990s when Terminator came out, and that it really started in the 1970s and when they environmentalists started to bash nuclear power. We had all these types of things. Like, that's where sci-fi started getting dystopian. And now we're at the end. We're at the point where, okay, we do have this novel form of intelligence. It is a cognitive prosthetic. People are forming relationships with it. And we also have drones that is the Skynet type of thing. It's like the military applications of this technology are also really important to think about.
Well, I believe you're wandering a little bit, but the endpoint of AI is when it can control the physical plane, which it can't do right now because our robotics aren't good enough. But there is, you know, they got these humanoid robots, right? Tesla has one, but there are a bunch in China and I don't remember the other companies. But there are people think that, you know, what you really need is to have a human form for the AI that exists in a form that looks like you, vaguely at least, and can manipulate the physical environment, pick stuff up, and, you know, potentially even have sensors that feel, touch, be able to smell, sight, all the 5 senses that we have. And until we have that, there are a lot of people believe strongly that until we have that, we don't have true AI, because AI is stuck inside a computer. It can only be a virtual character. Mm-hmm. So even if that virtual character has all the data that you're talking about, including science fiction, because it can't leap out of the computer and grab you, it's still not.
I mean, I get the point on the robotics part, but we're talking about the internet and computer. This would be really interesting to start talking about how infrastructure systems started to network together as well. But like, our entire infrastructure is built off of the internet, right? It is connected to the internet. So our power grids are on the internet, our hospitals are on the internet, our trains and our planes and all these different things are on the internet. Is that true? Is that like, what do you think?
Not yet, but it's happening. Yeah. All of those devices you talked about, whether they're CNC machines in a factory or, you know, pulse monitors in a hospital, etc. Most of them are not connected to the internet because they were designed before the internet, and designing devices with the internet is still black art.
So, but this and an Arduino are the key to that, right? The Raspberry Pi and Arduino.
Not necessarily, because that's still fairly big. That thing you're holding in your hand is still physically fairly big. So you have to have some kind of thing attached to a machine, like a CNC or a milling machine, or even robots that put stuff together, non-humanoid robots. You don't necessarily want it to have full computing capabilities. See how to say this. The more memory and processing power you have attached to a machine, the more capable it is, but also the more expensive it is and the more space it takes up. So, you know, maybe there'll be a generation of design engineers who can figure this out, how to put enough memory and processing powers in a small enough space that just becomes part of the machine. But similar to the difference between software and hardware, you don't want to commit that until your hardware is fully functional and has full internet capability. So the Arduino, or the thing you have, how's it called? Raspberry Pi, has processing and memory, but it doesn't have a full suite of interfaces, interactions that it can create. So you have to add hardware to it to make it fully functional. I don't believe that has an internet connection on it.
It does. It has a Wi-Fi.
That has
It has
Wi-Fi.
Wi-Fi. It has Wi-Fi. It has Bluetooth. It has a memory card. This, unfortunately, I could not figure out how to do it. I got this little tiny memory card. I believe this is the fail point. I tried to boot it from the internet, and it's just not working. So I need to get another one, and I need to connect it to a keyboard and an HDMI card, so that instead of trying to boot it from the internet, I can boot it from the software on it. But this is really interesting territory that we just discovered, which is that we have all these devices, and we've talked about your company, Device Authority, and I went and did research on them, and it's a very interesting company. So we have all these devices, and so let's say a CNC machine. I imagine you could put one of these on a CNC machine and get it connected to the internet. Mm-hmm. I've missed the point about there's the problem with the hardware, and this gets to a question I want to ask you earlier. You said you don't give the something about the hardware that it can't change. The software can change, but the hardware can't change. So the software can change, but the hardware can't change. And what kind of things can you tell the hardware to do?
So I'll just describe Device Authority, because it is actually the reason we invested in the company. Is it's sitting at that intersection between we're talking about coffee. Yeah.
Stat. Get him some coffee, Stat.
So factories and hospitals were built with devices that were not connected to the internet, because there was no internet when it was originally designed. So when you say you don't want to change the hardware, you do change the hardware over time, but you have to replace the hardware with improved hardware that has more capabilities. If you want a personal computer, it has a screen on it, an operating system. You're already in, the form factor I'm sitting in front of here, which weighs a pound or two, and so there's some constraint on hardware that is controlling the machine. In the case of Device Authority, the key feature they have is the ability in real time to update over the air, called over the air, right? So you have to have some form of Wi-Fi or whatever it is, so that you can send an update to a device. So most devices don't have, the devices that already exist don't have an internet connection, neither Wi-Fi nor Bluetooth or anything else. So then you have to replace that hardware with hardware that does have, and that's an IoT, Internet of Things, things being the device. And so in the Internet of Things, all devices are addressable, unless some of them aren't. And then of those that are addressable, what they designed with the ability to update their systems in mind, was the hardware designed that way. So you have to have a full computer attached to everything. But some of those things are really small, like drones, or whatever. So, you don't have a living, breathing internet. Internet, until all devices are on the internet and can be updated in real time. And this has been Device Authority's problem as a company. That's a very advanced concept. So when you're selling to companies, are going like, well, so what's it cost, and why do I have to do that? I already have all these machines. And, they can't understand the value of that. It's very complicated to do that. So Device Authority is actually doing something very sophisticated, and has been for the 10 years it's been around. But it's really a bitch to sell.
This gets us into really interesting territory about human beings, and some human beings are early adopters. Some human beings are attracted to technology. I think both of us are fit into that category. And it's like the water we swim in, but then 95% couldn't care less and are completely just totally ignoring not ignoring, are totally scared by the
Perfect.
fact of technology. So like you've got like mainstream society, which is, going back to the Skynet thing, they're totally freaked out, and for good reason. It's like it's going to change a lot of things. So what have you learned in your company building for a long time that about this gap between how often do businesses fail because of that gap?
It's an essential problem.
Yeah.
But one of Steve Jobs was well known for hating enterprises.
Yeah.
Didn't want enterprise customers. There's some very big companies like Oracle and IBM that only deal with enterprises, and they know how to do that.
Yeah.
But he considered IT people and IT people, information technology, the people in between a company and the vendors.
Right.
And they're, as a class, I can find some of them very interesting, but generally speaking, their whole job is to avoid risk.
Yeah.
And this did not appeal to Steve Jobs and to a lot of other people too. It's like they don't seem to be independent minded. They seem to be more like drones operated by the company, but you can't quite tell why or how.
Interesting.
And really high order IT people are in a different class. I think I've talked about United Airlines, but it's in general the interface between vendors and the company when it comes to information technologies. If they were smarter and more motivated, they'd probably be working for the vendor, not for the customer company. It's basic dynamic. And as systems become more flexible and more intelligent over time, you can imagine that perhaps the class of people that AI will be most affect will be IT people, because the system is smart enough to know what it needs and what it's capable of.
Yes,
I got my coffee.
Yeah, now you got it. So this is a good point. Is like what do LLMs do? In my opinion, they serve as cognitive prosthetics. So it can turn a smart person into a smarter person, but it can also turn an average person into a smarter person.
So how much do you need to know about what we have right now is generative AI? It's not through AGI. So we'll see how this works. But how much does the user have to have curiosity about how the technology works in order to use it most effectively, in order to make themselves smarter? And always in technology, it tends to be the leading edges, people that are curious, intellectually curious, and want to understand what's going on, who end up kind of interfacing with new systems most readily and getting benefit from it. I mean, I used to say, this is just a little side thought, but people would ask me when I started in the personal computers, how do you buy a computer? What do you need to do? And I go, my thing was buy a Commodore 64 for whatever it was, $99 at the time, play with it, and then throw it away, and you'll know more about computers. So if you really want to know, buy something cheap so you get some experience using them and you can kind of figure out what the questions are. We've kind of gone past that now because the smartphone everybody has one.
So it really comes down to curiosity, and curiosity is an interesting thing, because I found that a lot of people can be highly intelligent and completely incurious and have no curiosity whatsoever, which I find really interesting, because I feels like intelligence and curiosity are related. But this actually goes into Leonardo da Vinci. I think Isaacson biography like the thing that he highlights in da Vinci was that he was curious, not that he was intelligent. He was curious. That's why he's so prolific.
Or I don't know if Isaacson didn't want him, Ben Franklin, but he'd be a similar kind of character.
Yes.
He figured out electricity.
Yeah. Is that true? Did you find that as well? What is your take on the relationship between intelligence, IQ, and curiosity?
Well, I think it's what defines humans. So if there are 8 billion of us, probably not all of us are curious, but it is curiosity that defines humanity.
Yep.
And the ability to figure out what to be curious about, what to look at. Like program system like computing is not likely to have inherent curiosity. This is part of why I think humans will always have a role to play in all this stuff about, Skynet eliminating us. I think is bullshit. Because the thing that distinguishes us is curiosity.
LM is not curious. It is not curious. It has no curiosity.
It knows the answer.
Yeah.
It could confidently give you a hallucination as an answer. A lot of confidence. Humility. I mean, these words that apply to people, just they can't. I mean, I just don't think that'll ever happen.
Yeah. It might be able to simulate it, but it won't be able to do the real thing.
Yeah. Mimic.
Are LLMs curious or humble? And it just feels like it doesn't apply. It's like not applicable. That feels like the type of thing. Okay, this is really interesting territory.
So combine that curiosity with operating systems. You have to get some sense of what you need to know to understand computing systems.
Yeah, that feels like a good part. Okay, well, feels like a good place to end it. So that was a fun one, and tune in next week.